So you're on assignment number 18. And I think I'm going to need you to read it to me. Would you mind? So what are we going to do first? So we're going to add it and get 0. And then what? So we're going to wind up with the absolute value of 3x minus 2 equals 0. There are 3 things that can happen at the end of one of these equations. Number one, like when you get to the next assignment, you just always write 2 equations because there'll be variables on both sides. But for this assignment, either there's going to be no solution, which this clearly does not fit into that category because 0 is not negative, or you're going to split it into 2 equations, or there's actually a possibility that there's only one. And when all you have is equal to 0, then that means that there's only one equation. So when we write that one equation, we just basically copy the problem. We copy this down just without the absolute value. It has to come off. So we say then that what's inside, the only way to make this equation work is if that equals 0. And then you solve that equation and you add 2, divide by 3, and you get your one solution. Yep. Got it? Any other time you would either have the 2 Splitsville equations, or you would just say no solution, depending on the situation. All better?
Yeah.
Okay. I'm going to have to ask you to read it to me again. Sorry.
Minus 2 equals 7.
Equals what?
7.
Okay. So same mechanics. We're going to add 2. And we're going to get negative 6 times the whatever thing we're trying to get by itself, right? Equals 72. And then we're going to get the absolute value of 2x minus 6 equals what?
Well,
Mhm.
yeah.
And then what?
I did the 2x minus 6 equals 12, and then 2x minus 6 equals 9.
There is no solution. Absolute value, this machine, this red machine, by definition, regardless of how hard you try, no matter how many millions of times you fumble around in here, you can plug in whatever you want for X, anything in the world. Never in a trillion years is that red machine ever going to say, here, I spit you out an answer and it's negative 12. Absolute value as a machine does not give out negative answers ever. Never.
Oh,
Because the absolute value is trying to equal negative 12, any work you do after this is technically incorrect. You need to stop right there, say no solution, go to the next one.
I did it.
The only time you're going to write the 2 equations is if this number, this yellow number over here, is a positive, then you'll split it into those 2 equations. Okay. Cool. So I assume that you subtracted 2 or 9 from both sides, and that you got the absolute value of negative n plus 7 is equal to 2. So problem 1, we got 1 solution. Problem 2, we got no solutions. This is our first one where we're going to get 2 solutions, because the absolute value can produce the number 2 different ways. And one of those ways is if the stuff inside equals actually 2. The other is if the stuff inside equals negative 2. Those are 2 possible scenarios that would make this equation true. You agree? Okay. So on the first equation, if I subtract 7, I get negative 5. But since negative n equals negative 5, we have to divide away that negative, and we figure out that n actually has to equal positive 5. And then on the next equation, same kind of logic. If I subtract 7, I get -9. But again, it's negative n that's equaling that, and I don't really give a rip about negative n. So I divide away the negative, because if negative n equals -9, then positive n has to equal +9. Done. That's it. And as always, you're welcome. I stopped making kids do this 20 years ago, but you're welcome to plug them back in. It's what's nice about equation tests like this is before you turn in a test, you can always grade your own paper essentially. Again, literally hardly anyone ever does, but like you could grade it yourself by putting your answers, what you think are your answers, back up in here and see if they actually work. And so that's nice to know. But again, hardly anyone ever actually does that, but you could. Yep, no problem. I'll just keep this up here. So sure. You don't mind, I'm going to skip some of the first steps. I assume you know that we have to subtract 2 and get -51. And then I assume you also know that we have to divide by -3, which is going to give us the absolute value of 8 minus 9n equals the answer to that division problem, which is +17. So this is one where we're going to split it into 2 equations because that's what we do, right? Remember, what we're trying to say here is this stuff inside that I'm underlining, that stuff inside could equal 17, or it could equal -17. So one of our equations is a statement of that. And the other one is a statement of that. We just don't know. So we have to account for both possible scenarios by writing 2 separate equations like that. So to solve the first one, you would subtract 8. You agree? And 17 minus 8 is 9. And then if you divide that 9 by the -9 that's attached to n, you figure out that n equals -1. So that's one of your solutions. But again, you want to check it and just, make sure. And then the other one is going to be subtract 8, and you're going to get -25. And so I'm guessing that this is probably why we're going over this, because it comes out as a fraction. And remember that fractions don't mean we've done anything wrong. Fractions just happen. Not all numbers come out nice. And so like on this one, I'm going to show a little more work. If I subtract 8, I get -9n equals -25. And then if I divide by -9, I actually just get something that is what it is. And that's it. And if you wanted to check that, it's actually not very difficult, because if you go up here and put it where this little red arrow is pointing, what's nice is the math is actually pretty basic. I know a lot of times people say fractions, ooh, scary, but if you put 25/9 in there, the nines actually just cancel out, and it's really easy to do. Does that make sense? Okay, cool. So these ones, you're always going to have 2 equations. Because the variable value on the right-hand side tells us that we can't really make a snap judgment like we've been able to in the past. We've been able to look right at it. Once you get the absolute value by itself, you've been able to say 1 equation, no equations, 2 equations. But here, because of the x, we're not actually going to know. So when you get the absolute value by itself, it's going to say the absolute value. Oh, that pen is too thin. 5x plus 4, is that what you said? Plus 4? Yeah, can't be doing stuff like that. And so what we don't know at this point in time is what this is. Is it positive or negative? Like if we could say that, then we could make a choice, but we don't have that. We don't know. So one of the equations is going to be essentially a carbon copy of this with the absolute value off. Okay, remember this does not count as one of our 2 equations. So one of them is going to be maybe 4x minus 4 equals what I actually see, 5x plus 4. The other equation is going to be that maybe 4x minus 4, the stuff inside, equals the opposite of the right-hand side. And because it's a binomial, we have to negate both terms. So the 5x becomes -5x, and the plus 4 becomes -4. You understand that? And we have to account for both of these situations. And then sometimes at the end, one of the equations will produce maybe one or both or none. We just have to check the answers because sometimes bad answers just show up. So if you look at the red equation, so like if I move the 5x over to the left, I get -x, -1x, and then I add the 4 and I get 8. So x equals -8. Okay, so that's a potential solution. We don't know yet. And then for the purple equation, if I move the -5x over, I get 9x. And then if I add 4, I get 0. So the red and purple numbers down at the bottom are the possible answers. So we have to check them. And if you check the red one, -8, you realize that it can't work. And you don't even need to do, you don't have to do the math. Can you see where I'm moving my pen? You don't have to do that because if you put -8 right where this arrow is pointing, 5 times -8 is -40, and -40 plus 4 is -36. And as we discussed earlier, the absolute value can never produce -36, not in a trillion years. Therefore, -8 is not a valid solution. You cross it off. And if you put in 0, this one you actually have to do a little bit of work. If you put 0 where these two purple arrows are pointing, so what's 4 times 0? And what's 0 minus 4? And what's the absolute value of -4? So we have 4 equals, and then on the right side, 5 times 0 is 0 plus 4 is 4. 4 does equal 4, so x equals 0 is the only solution to this. Again, sometimes they'll both be extraneous, bad, the ones we cross out. Sometimes they'll both work just fine. Just depends. Yeah, no problem.
And so what happens if there's that? So, yeah.
Just again, write the two equations. So because there's no prep work to do, the absolute value is already by itself. So we can go right into either 4x minus 6 equals exactly what we see, or correct. And so again, when you solve these on this one, you're going to get 2x equals 6, x equals 3. And then on this one, you're going to get 6x equals 6, x equals 1. And you can solve those equations as slowly as you are comfortable with. That's up to you. But 1 and 3 are the candidates at this point. So you'd want to go back and check them both. They both have a lot of potential here because if you put either of them where this red arrow is pointing, neither one of them is going to make a negative. So that's a good sign because those are both like really strongly possible. So if you put in 3, 4 times 3 is 12, minus 6 is 6. The absolute value of 6 is 6, and 6 equals 6. So 3 is good. And then 1, 4 times 1 is 4. 4 minus 6 is -2. The absolute value of which is 2. -2 becomes 2, and 2 does equal 2. Therefore, these are both solutions. So this is one where you'd have to type in 3 and then hit the additional solution, this little button right here. So again, on this section of problems that you're working on, sometimes you'll have one good, one bad. Sometimes you'll have two goods, and sometimes you will have two bads. In which case you'll hit the no solution button. Got it?